Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes on the beautiful lesson on similarity of triangles. The word similarity in your life will come across at many places. Is it not? Even our body is also has got so many similar things. Look at your eyes. They are similar. Look at your ears. They are similar. Hands, legs. Is it not? So also in nature also we may get lot of things which are similar. We might have seen two lions in the front of a temple or two elephants kept at the same distance from each other. Is it not? So they're all called similarities. Even two towers of a beautiful Gopuram, you have two pillars. They will be similar. Is it not? So like that, go on making list of similar figures, similar solids. Now we are studying about similar triangles. And what is the difference between similar triangles and similar congruent triangles? Congruent triangles means they are both in shape and size, they are equal. Whereas similar triangles means in shape they will be equal, but not in size, need not be in size. Is it not? So, and similar triangles, and there are similar quadrilaterals, similar circles, similar squares and so on. Their sizes are different. The dimensions may be different. But shape must be same. Here, shape and size both must be same. Is it not? That you already studied in the previous class. And also you have seen about basic proportionality theorem, also called as Thales theorem. What does the theorem says? When a line is drawn parallel to, in a given triangle, if a line is drawn parallel to the base, suppose this is parallel, then that line divides the other two sides proportionally. Means AD by DB is equal to AE by EC. When D is drawn parallel to BC. And converse says, if these two segments are equal, AD by DB is equal to AE by EC, then BC is parallel to DE. That is called converse. Okay? It's also called Thales theorem because it was discovered by Thales, a Greek mathematician. And also we have seen about bisector of an angle of a triangle. What is the property of bisector? Suppose in any triangle, for that matter, if a bisector is drawn, this bisector, the segment produced by the bisector will be in proportional to AB by AC, proportional to the sides. Suppose you call it as D here, and AB by AC will be equal to BD by DC. When this bisector is drawn. What do you mean bisector? Bisector is a line which divides the angle equally. So the angle is 60 degrees. So if you draw a line then the two angles will be equal to 30 degrees. Then this line AD is called bisector. And what happens if a bisector is drawn? AB by AC, the ratio of the sides of the triangle, is proportional to the segments formed by the bisector, BD by DC. That is what is called bisector property of a triangle. Okay. And also we have seen about the criteria for similarity. A. What is that? Come on, expand. A means what? Angle. So in the two triangles, if the three angles of one triangle, suppose you call it as ABC and one more triangle called PQR or DEF, you can call. Angle means if angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, then the two triangles are said to be similar. How to write similar? Sleeping, yes. Triangle ABC is similar to triangle PQR. Actually, two angles are sufficient. Because if two angles are equal, then third angle must be equal. That is understood. Anyway, it is called A similarity. Then you have SSS. SSS means what? The three sides of one triangle is equal to corresponding three sides of the other. Then the two triangles are similar. And SAS, two side and one angle of one triangle is equal to the two side and one angle of the other. S means side, A means angle, S means side, two side and one angle, and that angle must be included angle, not other angle. Then also we call it as similar triangles. So don't forget AAA, SSS, SAS. Okay. So this is the thing we already seen. Now we'll pass on to home assignment. So first question, in the figure, RS is the bisector of angle R. So this is the bisector. What do you mean bisector? It divides the two angles equally. And then for the given dimension, express P. You are given that PR is X and RQ is Z and PS is Y and QS is P. They are asking you that length of QS in terms of XYZ. So length of QS is called P. You have to express that P in terms of XYZ. Here no value is given. They are given algebraic terms. So what is the first step? RS is called a bisector of angle R of triangle PQR. So this is a bisector. So what does the bisector property says? Just now we have seen ratio of the sides. See, there are two sides. One is called PR, another is called QR. So PR by QR is equal to, it forms two equal line segments, PS by QS. PS by QS. That is a bisector property. What is PR by RQ? PR by RQ is X by Z. See, this is X, PR is X, QZ is Y, RQ is Z. So, X by Z is equal to two segments here, PS by SP, that is Y by P. In this, if you want to find out P, so here what happens, you can write like this, P into X, cross multiply, you get P into X is equal to P into X is equal to Y into Z. Now they are asking express P in terms of XYZ. So P is equal to YZ as usual, numerator, denominator will be X. So that is the answer. Noted? Very nice. Simple problem, provided you know this property. Okay. Now we will pass on to second sum. Find the value of triangle ABC. Find the values of X and Y. Find the values of X and Y if triangle ABC is similar to triangle PQR. Here you must note, so you are given that triangle ABC is similar to triangle PQR. So there are two properties for similarity here, angle, 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 and sides are proportional. Anyway you can take. Here let us see only angle, angle, angle. Means what? So angle A of the first triangle and angle P of the second triangle, they are equal. Is it not? Now in the second triangle, the angle Q is 70. P, B and Q are equal. So first point, angle A is equal to angle P is equal to 60 degrees. And second point, that is angle X, angle B is equal to angle Q is equal to 70 degrees. These two angles must be 70. Therefore, you can write X is equal to 70 degrees. Coming to third angle, that is C is equal to R. They are corresponding angles, na? That is 50 degrees. So therefore, you can write Y is equal to 50 degrees. That is in confirmation with the angle, angle, angle similarity. Okay, noted? So nice. Now coming to third problem. Which of the following cases triangle ABC and triangle PQR are similar? So that is one condition. Here you see A is equal, A and P are equal, corresponding. Suppose you draw a triangle. ABC and PQR. You are given that A and P, they are corresponding angles, they are equal, 50 and 50. 50-50 are equal. Now those two angles are equal. Now second angle, angle B is 70. Here angle Q must be 70, but they are given 60. Therefore, the angle B is not equal to angle Q. Therefore, they are not similar. Similarly, angle R is 70 given. Angle R is given to be 70 and C should have been 70, but it comes to 60. So, therefore, you can say they are not equiangular, and therefore the two triangles are not similar. That is the first case. Second case, AB, BC, CA, sides are given, PQ is given, PQ 5. So, AB and PQ are proportional and BC and QR are proportional. CA and RP are proportional. So, AB by PQ, ratio of sides, corresponding sides, BC by QR is equal to AC by PR. As the ratio of sides are equal and all of them comes to 1 by 2. See, 2.5 by 5 becomes 1 by 2. 4.5 by 9, again 1 by 2. And 3.5 by 7, it comes to 1 by 2. All of them are proportional, and therefore we can say the two triangles are proportional. Got it? Very nice. So that is the end of this homework. We'll come to today's topic. Today we have some important results of the right angle triangle. If a perpendicular is drawn from the vertex of the right angle of a right angle, so this is a perpendicular drawn in this triangle. All of you draw it using pencil and scale. Okay, so dimension may be anything. If you draw it in a right angle, 3, 4, 5 is well and good. That is one side as so here the angle is 90 degrees. So you can write this is 5, this is 3 and this is 4. That will take intake. So this is the hypotenuse. So BC is the hypotenuse. So what they have done, if a perpendicular is drawn to the hypotenuse from the opposite vertex, then what does it do? The triangles on each side of the perpendicular are similar to each other. There are two triangles here. One is ABD, another is ADC. And totally they are in a big triangle called ABC. So this statement says they are similar to each other and to the original triangle. Original triangle means ABC. So there are three triangles now. Now we are telling that they are similar to each other. So what you have done here, this is only a verification. So draw a right angle triangle. You can also do it. As I told just now, take it as 3, take it as 4, take it as 5. Draw a perpendicular and check the angles. And right angle at A. So this angle is 90 degrees. Draw AD perpendicular to the hypotenuse BC, meeting it in D. Okay. And here you must take as 90 degrees using what is the device called? Protractor. Or you can do in compass also if you know it. So protractor will be easy. Okay. Then what do you get? So this is a right angle triangle you get here. So let angle DBA is equal to alpha. DBA is equal to alpha. As this is 90, sum of the all the three angles is 180 degrees. So this is alpha. Therefore, this must be 90 minus alpha. For example, if this is 30, this becomes 60. That is the meaning. 30 plus 60 and 90 here. Follow? To make it simple. And IDB is equal to 90 degrees. Therefore, BAD is 90 minus alpha. 90 minus 30, that is 60. And as BAC is 90, and BAD will be equal to 90 minus alpha. BAD. So BAC is 90. So BAC is 90. BAD becomes 90 minus alpha, and this is alpha. So therefore DAC becomes alpha because it is 90 degrees fully. So that is 30. This is an example I am giving. 60. So you have two triangles, ADB and CDA. If you take ADB, this is first triangle, this is the second triangle. What do you find? They are similar because all the corresponding angles are equal. So in first triangle and the second triangle, if you take, this is 90 corresponding angles. These two are alpha. This is 90 minus alpha. So corresponding angles are equal. Therefore, we can say they are similar. Triangle ADB is similar to triangle ACD. Similarly, if you take the big triangle, also angles BAC of triangle BAC. So big triangle if you take, that also will have the similar angles are equal. So you have three angles. One is alpha, another is 90 minus alpha. So the three angles of one triangle is equal to three angles of the corresponding angles of the second triangle is equal to the corresponding angle of the third triangle, that is big triangle. Therefore, we say triangle ADB is similar to triangle ADC is similar to triangle CAB, full angle. You may ask, why do you want it? This is required to prove the next theorem called Pythagoras theorem, also called as Baudhayana theorem. Before that, we have one more interesting aspect. Ratio of the areas of two similar triangles is equal to ratio of the squares of the corresponding sides. So that is another theorem actually. So if the two triangles are similar, then what do you get? The areas of triangle ABC is equal to area of triangle. If the two triangles are similar, the ratio of the area of triangle ABC and triangle PQR is equal to the ratio of the squares of the corresponding sides. Squares means what? AB square by PQ square, BC square by QR square is equal to AC square by PR square. That is the meaning. So that's a theorem. But for you, the proof of theorem is not there. You can do an activity. Take two triangles like this measurements 3, 4, 5, 3, 4.5, 5, 6, 8 and 10 centimeter using compasses. Draw two triangles. Okay. And then what do you observe? Draw AD perpendicular to BC. AD is perpendicular to BC is drawn. Similarly, PS is drawn perpendicular to QR. Why do you want perpendicular? What is the other name for that? It's also called altitude. Why do you want it? That is just to find out altitude, you can say, or you can say height also. So that is required, because if height is known, you can find the area. Half of base into height. This also half of base into height. So measure the lengths of AD and PS. So what is AD? That is the height. Here also this is the height. You have to measure it. So product of AD into BC. AD is the height, BC is the base. Similarly, here PS is the height and QR is the base. So find the product of these two. And if you multiply those two, you find the value of these two. If AD into BC is also equal to BC square, that is 5 square. Similarly, PS into QR is equal to PR square, BC square, QR square. Now AD into BC means what? AD into BC means 2 times area of triangle ABC. Because area of triangle ABC is half of AD into BC. Are you following? So area of triangle ABC. What is the formula for the area of triangle? Half base into height, right? So half of, what is base here? BC. What is height? Into AD. So bring this to this side. Then you get this. Okay. Similarly here, area of triangle PQR is equal to half of base into height. Base is QR, height is PS. Bring this to this side. So QR into PS is equal to 2 times area of triangle PQR. Got it? So what do you get by that? So we have a result, very important result. Area of triangle ABC by area of triangle PQR is equal to AD into BC by PS into QR. So AD into BC means what? BC square. PS into QR means what? QR square. So as BC by QR is equal to AB by PQ is equal to AC by PR. Why it is so? Because they are the sides, corresponding sides of the similar triangles. The two triangles are similar. They are the corresponding sides. They are proportional. So area of triangle, very important result. Area of triangle ABC by area of triangle PQR, or any number of areas you can take. Then what happens? Is equal to squares of the corresponding sides. The ratio of the squares of the corresponding sides means BC square corresponding is QR square. BC square by QR square is also equal to AB square by PQ square is also equal to AC square by PR square. And also you can say AD square by PS square. That is also there. Followed? This is a very important theorem. Now let us work out some problems on this. Find the ratio of the area of two similar triangles if one pair of the corresponding sides are 3 cm and 5 cm. So here, what is given? sides of two similar triangles. Three centimeters and 5 centimeters. You are given that, so let us call the two triangles, similar triangles, as ABC and DEF. Let us suppose they are the two similar triangles. So, that is in triangle ABC and triangle DEF, you are given that they are similar. So, you see AB by DE is equal to 3 by 5. You are given. So, you are given a name for that. You can give any name, X, Y, Z, P, Q, R, anywhere. So, that is given. So, to find, what do you have to find? Find the ratio of the area. So, area of triangle ABC by area of triangle DEF. Just now you have seen a theorem. What is it equal to? It is equal to ratio of the corresponding, ratio of the squares of the corresponding sides. So, AB square by DE square, that is 3 by 5 square, that is 9 by 25. So, that is the answer. That's all. One more question. So, you are given with one corresponding sides. So, square of that. That is by theorem. Theorem on the areas. Okay. That's all in the first question. Coming to second question. P, Q, R are respectively the midpoints of the sides AB, BC, CA. So, P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of AC. You have to show that area of triangle PQR. So, this triangle is there, no? Is 1/4 the area of triangle ABC. 1/4 the area of triangle ABC. So, you are given triangle ABC in which P, Q, R are the midpoints of the sides AB, BC, CA. So, this is a midpoint. This is a midpoint, this is a midpoint. You are given. In triangle ABC and triangle PQR, you have angle Q is equal to angle A, angle R is equal to angle B. So, angle Q is equal to angle A first, R is equal to B, and P is equal to C. Because they are similar. So, as they are equiangular, the two triangles are similar. And when the three angles of one triangle are equal to the corresponding angles of the second triangle, we call it as similar triangles. So, this is the angle number 1 and this is angle number 2, angle number 3. They are called AAA similarity. Now you may ask why they are equal. Because they are the opposite angles of a quadrilateral. This is quadrilateral, no? PQRS. And therefore, these opposite angles are equal. So these two are equal, these two are equal, these two are equal. Is it not? So you have, they are similar. If they are similar, by theorem of area of triangle PQR, this small triangle inside is equal or by, not is equal to, area of triangle PQR by area of triangle ABC, big triangle. So what do you have? Corresponding side. Corresponding side means what? In this triangle, you have QR is one side. It is QR square by AB square. That is for the big triangle, right? And it is equal to, QR means how much? Q is the midpoint, R is the midpoint. Therefore, line joining QR is half of this. Half AB square. Half AB whole square by AB square. Half AB whole square means how much? It becomes 1 by 4th AB square by AB square. So when you divide that, AB square cancels. 1 by 2 square means 1 by 4. That means what? This means that this triangle area, PQR area, is 1/4 the area of triangle ABC. That is the meaning. Area of triangle PQR is 1/4 the area of triangle ABC. Followed? Here is important point you must notice. First, you must know they are similar triangles. Number 2, you must note line joining the midpoints of the two sides of a triangle is half of the base. Half of the base. That is, QR is half of AB. Similarly, PQ is half of AC. Similarly, PR is half of BC. That you must note. So, by theorem, the square of that sides you must take. When you square it, it becomes 1 by 4. So, this is the answer you get for the problem. Is it okay? Okay. Now, home assignments. In the figure, ABC is a right triangle. Angle A is 90 degrees. So, this angle is given to be 90 degrees. Angle C is 30 degrees. Show that triangle DAB is similar to triangle DCA is similar to triangle ACB. Same type you have done once, but here the values are given. There we took it as alpha and all. So that is the first question. Taken down? Okay. Second question. In two similar triangles ABC and PQR, the corresponding altitudes AD and PS are in the ratio of 4:9. Find the ratio of triangle ABC and PQR. You are given AB by PQ sides, AD by PS altitudes, BC by QR sides, CA by PR, the corresponding sides. So, using this property, you have to find the ratio of triangle ABC and PQR. Now comes next question. If the ratio of the areas of two similar triangles are 16:25, find the ratio of their corresponding sides. So, areas are given in the ratio. Find the corresponding sides. Now, let us see what Sadhguru Madhusudan Sahi says. Uvacha means says. Very beautiful quotation. So, a thought, so an action, so a tendency, so a habit, so a character. So, what does it do? So, when you sow a thought, what are you going to reap? You are going to reap an action. So, if you sow an action, reap a tendency. Sow a tendency, reap a habit. Sow a habit, reap a character. Sow a character, reap a destiny. This is what Sadguru Madhusudan Sai says. So come prepared with the answers. Thank you.